I don't know, like $500 a month and $2,500 up front. And like I saw a lot of people like on the internet kind of like losing their mind of, oh, it's getting so much more expensive. And I'm over here like, if I can have reliable internet for $500 a month, I will pay Elon up front for the next 10 years, right? Like let me write you a check for $60,000 if you can guarantee my internet for the next 5 years. Go launch me some more satellites, right? Like whatever you have to do, it doesn't particularly matter, because
Right.
When it's a business expense, it's cheap.
That's right.
I mean, to be fair, I guess you have a different lifestyle than everybody, Dave. So I don't know if I'd be willing to fork out.
So Dave's living in the future.
But,
Dave's living in the future. Everybody try to keep up, okay?
but no, I guess my point is, Vlad, like you probably spend $100 or more a month on internet where you are.
Yep.
But if you're rural out in the middle of nowhere, there is no high-speed fiber. There is no high-speed, copper. So what most of those, like Starlink makes it possible to go ahead and potentially do some of those things. And if you're a business, you're paying $500 or $1,000 a month for internet at your location, like without a doubt. So
think of what you're saving on your mortgage. Yeah. Anyway.
No, but so my point is, if it's a business expense and you're using business internet, then $500 a month is cheap, in the grand scheme of things.
Yeah, I'd be very curious, even from like a larger business standpoint that operates remotely. Again, for some of these plants, it's probably comparable in cost if you're going with a source that needs to be brought to a remote location. But those of us who are joining us right now live, we are talking a little bit about Starlink. David was visiting Maine for a number of weeks and was telling me and Dave off stream a little bit before we started on how that experience was. But I'm curious to see again, like how it's going to be rolled out. As I had mentioned, Hank Priam had also got the connection, so I'm curious to see or hear his thoughts on that. But in any case, we are live. I see us on LinkedIn. I see us on YouTube. Dave, you want to get us started with a few community comments, maybe?
I do. And so everyone will have to remember back 10 or 15 episodes when David Nichols was on last time. And I think Vlad made the comment of Dave and we both started talking. So welcome back like 2 months ago, but also into the future where there are 2 Daves on the show. But no, so we've got some exciting community announcements. I'll change it up a little bit and embarrass Vlad to begin with. So if you guys don't know, Vlad runs Solus PLC, which is a successful YouTube channel. They've crested 28,000 subscribers on the way to the silver play button. So let's wave to everyone on Solus PLC. Thank you guys for joining us. If you guys have not subscribed, this is my ask that you guys go ahead and subscribe. It helps the show. It also helps Vlad, and we really want that silver play button, mostly just, I don't know, because we can. At some point, I'm just going to have a 3D printed silver play button sent to Vlad, and it's just going to confuse everyone because we're going to force him to share it on stream. So Dave. Please go. Of course, Vlad won't ask for that, but I will ask for that. Speaking of, well, slightly different, but we have an exciting announcement. So the Manufacturing Hub, this show has expanded shows that we do, right? So Max Krug, episode 33, and I have started a show. It's called On the Shoulder of Giants. Again, so we're going to discuss what we call generally operational excellence, and it's going to focus on achieving breakthrough results by establishing alignment throughout an organization. So episodes 1 and 2 are out now. It's a little bit of kind of the backgrounds of Max and I, and it's a little bit of what the beginning of one of these look like. It's very exciting. It's going to be a different structure than this show, but we ask you guys to go ahead and check that out. I will go ahead and drop a link in the comments below. Talking about Max and some other upcoming events. So Max has a LinkedIn Live talking about reformulating mindset for breakthrough organizational improvement. Max and I are going to have to work on titles of things, but I will go ahead and drop that below. Really mind-changing stuff that Max is doing. And you think that you're right on things, and then he lets you play a simple game, and you realize literally your entire life has been a lie. But I'll go ahead and drop a link to that below. And then thirdly, so announced for March 30th, the ISA is holding their IIoT and Smart Manufacturing Conference. It's a virtual conference. It's going to be a jam-packed schedule. I know I'm part of the conference committee. It is free for anyone who wants to go ahead and sign up for that. I absolutely suggest you guys take a look. listen to a bunch of great speakers. There's some networking in there as well. But with that, like, let's get into the show. And as the last comment, I guess Vlad has a comment. But before that, we do. I
was gonna mention, Dave, that if you're listening to this or if you're watching live, there's gonna be links posted in the chats on LinkedIn and YouTube. And if you're listening to this in podcast form, it's gonna be all like in the show notes for the URLs for these events that Dave is mentioning.
Absolutely. I'm actually going to do that on the live as soon as I get done with the community comments. But let's go ahead and jump into the robotics theme. So everyone, welcome to Manufacturing Hub with me, Dave, and this guy up here, Vlad. We've got a very special, I guess, repeat guest, David Nichols of Loupe. They do some really awesome things they do some really awesome things, hard stop, but they also do some really awesome things with robots, which is what I'm excited to talk about. So typically the very beginning is a background of the person. David covered that very well in the beginning of episode 29, which we'll drop links below. So David, do you want to give us maybe a brief history of what you and Loupe have been doing with robots over the last 10 or 15 years?
Yeah, sure. I'll give the let's see, 3-sentence explanation of what Loupe does, just in case people aren't in the deep back catalog yet. Definitely go check that out, because that was a really fun conversation about CI/CD systems and things like that. So yeah, we dabble in a lot of stuff. The reason we dabble in a lot of stuff is because our mission is really revolution at Loupe. That's applies to technology and automation, making incredible new kinds of machines. And so a lot of our work has involved software and motion control and robot dogs, and anywhere where there's these new kinds of technologies lying around and people are putting them to work in new contexts. To get real nuts and bolts about it, we have a distribution team that's called Widget. So we sell hardware, we sell control hardware, we sell B&R industrial automation PLCs. So and controls and motion systems, and that was really where we got our start a long time ago. It's like I was really interested in that technology. I was an application engineer. I was putting my laptop onto garbage can lids to make machines work, as we all do, and I was just so excited about applying that technology. And so the theme of Loupe is taking those new technologies and innovating and doing interesting new things. It's a different kind of work than building another car factory, let's say, which again, I also have a ton of respect for, and is super hard and et cetera. But like when there's new things to be done or people have new ideas, that's what we're excited to work on at Loupe. And so, yeah, robots and robotics have shown up, maybe midway. I mean, it's interesting because we came really more from a motion control type of approach. And when I came out of school and when I started working and when we started this company, it was seen almost as a distinct group. It was distinct, like the worlds didn't really overlap. So these are motion control people. These are vision people. These are robotics people. They don't, the channels are different. The suppliers are different. They hardly overlap. That was my experience of it. And so coming at it from a motion control point of view and being a high-tech automation distributor, we would sell motion controllers, we would sell servo drives, we would be working on control systems of machines, often with OEMs and things like that. And so we were more in the nuts and bolts of making really sophisticated motion control systems work. B&R is really good at system, I guess if you haven't heard of B&R, if you've seen any Crohn's bottler or any giant bottling machine that's running 20,000 units an hour, 60,000 units an hour, whatever. Often there's a ton of B&R motion control in those machines to make them run. And so B&R really has that's what they were about often, like those types of really challenging applications, super high speed. They've done a lot of innovative stuff over their history in motion control. And so that's why I got into it. That's the kind of thing that we worked on. And sometimes you'd be like, oh, we're working on a water jet cutting machine. By the way, a water jet cutting machine kind of looks like a 6-axis robot almost. It's more like a gantry, or it's more like a CNC. So, but from a control system point of view, it's a bunch of servo motors doing something really highly coordinated. It's controlled in real time. Oh, a robot is just some extra math on top of that. And so that was our entryway into robotics. we're used to doing these sophisticated motion control systems. And if I look at that, actually, if I look at that 6-axis, it's just 6 servo motors and some metal between them, some gearboxes. And so we weren't coming at it from like you would if you were given, you know, somebody put a pendant in your hand and said, you know, program this robot to weld sheet metal together, which they're really good at. We were thinking of it more at a lower level. And B&R started coming out with these new application packages and new ways of controlling 6-axis robots, just as if it were another 6 motors in your 30-axis machine. Like everything was integrated. Everything was really integrated together in one controller. That's still something that's very special and interesting about what they do. And that was our entryway into it. And so instead of being a package where it's like a cobot, or it's, you know, now we work with ABB and robot, you know, think about like Robot Studio, you're programming your robot to do things. It would be more like building a robot from parts, but with a real actuator. And so the applications where that was really valuable, because we needed to do sophisticated software things. We needed to integrate 30 other axes at millisecond level precision to do carbon fiber layup, or, you know, we needed to enhance the controls of them to take this basically cheap, I'm using finger quotes if you're not seeing the video, cheap robot, and augment it with all this extra stuff. Those applications were where B&R controls and the flexibility and what B&R can do with software was really valuable. So that was how we got into it. And then in the meantime, just started learning more about robots in general, and, you know, hooking up with ABB and kind of getting exposed to the world of robotics in that way. We kind of drifted into robotics through those applications and from a machine design point of view. If that makes sense.
David, so just to clarify, if I may, so on the B&R side, they provide, I would guess, the servo drives and perhaps like the gearboxes, and then you can create a CNC machine that's, you know, based on their platform, or where do they fit into the like robotic space?
Yes, you do that. You can do that. That was how we got started, was they started building all these CNC control systems, you know, for controlling 5-axis, for controlling custom kinematic systems. You could build, you know, they're basically providing like open CNC controller for you to go in and hack around with. And they have a lot of components that do that. That was how we started to get exposed to systems that had kinematics, right? Kinematic, whether they're serial or parallel. We started getting involved in those applications from a controls point of view, because B&R started bringing that stuff into their platform. And yeah, we worked with the company Flow International that makes water jet cutters, and we did their controls. We worked really closely with them for many years to do motion control of water jet cutting, which is really sophisticated and interesting process. So yeah, we did a lot of work in CNC, and then it's just a slight turn to the left over here, and let's control 6-axis. And so just going back into history, we started working with a company, Coma, Coma is a giant automotive integrator that's owned by, I think they're owned by Fiat, or maybe they got spun out. I haven't kept track, but they have their own robotics company within their integrator called Coma Robotics, and some people have heard of them. Coma actually used B&R as a supplier for their motion controls. So if you open a Coma cabinet, like you would open an ABB cabinet or a Fanuc cabinet, it's full of B&R drives. And so we were doing things like, hey, great robot you've got there. Thank you so much for sending us that robot. Like, we'll unplug your computer, we'll plug in our computer. Now we have complete control of everything just by plugging in real time, right? That was what we were super excited about. So that was how we started basically hijacking or hot rodding robot control systems to do our bidding from. And again, it's not easy. Like, we learned a ton of stuff about how to do that, but that was maybe 5 years ago. 5 or 8 years ago that we started getting into that pretty heavily, because certain markets and certain industries like aerospace have been really pioneering in that, taking robotics and applying them in new ways. I haven't ever worked with them, but like if you look at companies like Electroimpact and you look at the videos that they put out for doing carbon fiber layup or accurate hole drilling, just incredible equipment. They would do things like buy a KUKA, throw away the control cabinet, put a Siemens CNC in front of it, and trick it out, and turn around and charge $3 million for it, and do a ton of them, right? And they were super successful doing that. And so that was really inspiring, of taking those things that are basically sitting around, or like the automotive industry has gotten those actuators up to scale, so they're inexpensive for what they do. Let's augment them. Let's take these things that are lying around, like if you looked at the parts list of a robot, you couldn't buy half those gearboxes for what a robot costs. It's incredible how inexpensive it is. Just, they're full of expensive parts. Somehow, the whole robot only costs, 5 figures. It's great. It's wild. So that's why we got really interested, is we can take these and put new things around them and use them in new applications. Or, it's still unusual with B&R that you could take, often you'd be like, you can't really crack the robot controllers because the robot suppliers consider them proprietary. They don't let you really get in and hack around in real time. They have sometimes, a lot of them have good interfaces, but so what I guess I'm just sort of saying, this was our sort of high end, or that was our approach into robotics. And now what we were doing with Coma is being done with ABB. ABB and B&R are talking about their machine-centric robotics concepts, where they're doing the same thing now with ABB robots, which is really exciting because ABB robots are great. ABB is a great supplier. We work with them really closely, and all of that kind of cool pioneering tech we were doing with this little Italian company is now like coming into the big leagues, I think, with stuff with ABB. So does that clarify your question, Vlad, or about
I think
how I got into that? Yeah,
it does paint I understand now like how B&R fits in. And if I may follow up in general, so Loupe, in addition to the more, I would say, traditional quote unquote robotics, you guys also venture out into Boston Dynamics, right? And I'm sure that most people listening or watching this have seen the clips, but could you maybe talk to us how that relationship came to be, and what exactly is it that you guys provide as like an integration service, or you know, like whatever that may look like?
Yeah. So we were working with some people in our like day job, I'll say, again, finger quotes, our day job as integrators and hardware suppliers with a company that is doing some really interesting things in construction automation. I don't think I should mention their name because I didn't ask them to do that. But basically, we knew some people, and they had previously, like one of them had a friend that went to work at Boston Dynamics, and we were really hitting off with this construction company. We had a great relationship. We didn't end up working together, but these two people were talking, and this guy, Brian Ringley at Boston Dynamics, was saying like, hey, we're looking for savvy integrators, looking for good integrators that might be able to work with this weird stuff. And they were like, you should talk to Loupe. They do weird stuff. Or they, we were having good conversations about like, yeah, let's really break this, let's really innovate here. And because of that relationship, we were introduced, and Boston Dynamics showed up and said, hey, can you help us? Or we're looking for people that can help our customers, because again, some Fortune 50 company is going to come to them and be like, we're interested in this. They don't necessarily have all the application teams. And, in the same way that we would work with a B&R or an ABB as an integrator or as a value-added partner, we would kind of help them do those experiments, or we would help them do integration. We would help them do, yes, the robot dog is super sophisticated and it has all this amazing technology in it, but also it needs to have a backpack and it needs to solve a problem, like applications engineering for Spot or for Boston Dynamics. Boston Dynamics does a lot of that, or they also have partners, or they have third-party things that are sort of packaged. Like they have a lot in construction and surveying, for example. You can just buy it off the shelf and just drive around a construction site. Like they have that stuff. But for other stuff where such and such power company wants something to go, they want to do a pilot and run it around, and they needed like engineering organizations or kind of application teams to help. And so, I think 3 weeks later, we took delivery of a robot dog, and we're like, hell yeah, like that's all I need to know. We'll figure out what to do with it. We'll figure out how to make money with it.
Let's, that was going to be my follow-up on that. Like, I'm really curious to hear some, maybe again, like use cases that you're thinking about, or that some of your customers, maybe, again, whatever you can share within the confidentiality agreements, but I'm curious what you see these dogs being used for on the manufacturing floors.
Yeah. I think with Boston Dynamics, I think the reason that it fits for us is that we're taking technologies and applying them in new ways, or we're taking brand new stuff that's like actually people aren't sure what it's good for, or it seems like it's good for something, but like we're really, it's new and it's kind of innovative and it's like very experimental. Like we're very comfortable in that space. And so BD is really on the edge of that, because I would say there's notions about how it works. There's notions of what it could be good for, but if you think about it as a designer, you're competing with an intern walking around with a clipboard, right? You're competing with just plug all the sensors in on an Ethernet cable. You don't need a robot dog to walk around if everything is instrumented. right? Like if everything has an IoT and is feeding stuff up to the cloud, you don't need a dog to walk up to it and look at it, right? So it's like, what is it good at? Where are the places where the value of its mobility, and kind of the fact that it can roam around is really valuable and solves a problem that otherwise would be like super expensive, really complicated. So examples that are extreme in that way are places like nuclear power plants, where for somebody to suit up or for anything to go into that space is going to be a huge problem or a huge ordeal. Send in the thing and have it roam around, because by the way, the power plant was probably built 40 years ago. And, you can take the instruments, you can carry stuff around, you can drive it around, you can teleoperate it because it can walk upstairs, right? Like even another good example is why robot dogs when you could make a little thing with tank treads? What about something with wheels? If you can drive around an RC car, then it's probably simpler or cheaper to do that. So do that, right? And I just think about like a SWAT team dog, or like a dog that can roam around and like do bomb. It's just like, yeah, it's fine. That thing can climb upstairs too. So I think the question is like, it's so compelling, but it's like, it needs to be able to, or it needs to roam around large space, and it needs to do it frequently. It needs to do it with a lot of instrumentation, or the instrumentation is so expensive that you only really want one of them for a huge facility. And it's doing things like it's pointing thermal cameras at all the transformers in a substation, right? And it just goes and does the rounds, and it's just taking pictures of like, oh, that transformer's heating up. So you can't put thermal cameras on every single transformer, but you could put one on a dog and have it roam around every day, and that keeps the power on instead of having it crack. Like it's the first time that there's not an outage, like it's worth it because that substation is in the middle of nowhere, right? Like those are the kind of applications where the value of the mobility, the flexibility, is like you're bringing those systems where it makes sense. And it's super compelling to look at. So sometimes like it's also spot as a celebrity. So like the other stuff we've worked on has been, we wanted to dance in a casino, and we want it to be in our Katy Perry's calling and she wants it in her music video. It's like, yeah, we'll help. We'll help Katy with that. It's in 10 days. Okay. Yeah. Like we'll go to LA and do that. Because it's so, and by the way, when we went to LA, which I think is fun, and as a Portland, Oregon resident, it's also like the antithesis because, I don't need to explain, you can Google the differences, but in LA with Spot walking around a music video set for a global pop superstar, it's the most jaded people you could imagine. Right. They've seen everything. They don't care. Like they're just doing their jobs and they're all professionals. Like, and they have, just like superstars walking by. They're like, they've seen it all. They've seen everything. Spot walks by and every single person is like, boom, eyes on Spot. Right. And so there's just something about it. That's just kind of magical and weird. It's like, it's really, really interesting to see it come face to face with it. So yeah, I don't know what that is. And I don't know if that's in line with BD's marketing material that it does that, but it definitely has that ability. So we like to play with it for that reason too.
Yeah, it is now. It may not have been in BD's initial viewpoints, but now that's probably one of the top 10 things we need to focus on is more Katy Perry music videos with 500,000 hits, right? I
think so. Well, Katy Perry videos, when we started looking at them, when we got involved in that, they were the first videos I saw on YouTube that had 1 billion views.
1 billion?
They had 10 digits of views.
What?
Yeah, it was like 1.2 billion. And
you've got a long way to go, Vlad. You have a long way to go.
I was just happy when I got a custom URL with 100 subscribers. So Vlad, all the subscribers of Vlad, Loupe, Loupe team, mash right? That button. Yeah.
Yeah. Less than 1 billion views probably total between all of them. Maybe in our lifetimes, less than 1 billion views total.
Yeah. Yeah. But
crazy.
To talk a little bit more about that, like it felt a lot like a startup. It felt a lot like a machine startup because everything's changing all the time. It all got built together. It all got built in the last 2 hours. Mm-hmm. And everybody's watching and there's a lot of money at stake. And the director points at you, okay, you go now. You have one take. You have, everybody. And if we had moments where, it's walking next to Katy Perry and it Katie walked just a little bit too close to it. And it's so smart that it moved a little bit to the side to not get hit by Katie, but then it tripped over a curb and just cartwheeled. And they're like, okay, enough of that, moving on. And the entire set moved, the entire production is like moving on to the next thing because they don't have time for that.
That's amazing.
That. Anyway, we did a bunch of stuff, but it was very intense. It reminded me of some of the most intense startups that I've been on because it was like, you better go now. And there were moments where we were sure, or we crashed or flipped it over in a rehearsal and we're like, we're not sure if it's going to get up. We're not sure if it's going to run and we haven't done our thing yet. Yeah, we pulled it off, but it had those kind of gut wrenching moments for sure.
David, for those of us who are curious on the technical side, we had a good question from Jonathan. And again, I'm not sure how much of this information you can share with us, but he's asking, what is the license cost for the Boston Dynamics development environment? And I want to add to that, like myself, I guess I'm really curious on that same note, what does the development for that platform look like? And again, as much as you can share, but, I can picture, let's say the traditional automation systems I've seen, robotics, I've seen AGVs. What does that like, again, if you can show the cost, but also what does the development look like for that robot?
Yeah, sure. So there's so much I could say about this. We haven't found a ladder editor for it yet. So fair warning out there to all the ladder crew, like it doesn't have that kind of a vibe. That's not what it does. So, and the other thing about Spot and our use of it is that it's almost like, it's a lot more like a robot, like programming a robot, like versus like programming a PLC. Like programming PLC is like way more open in terms of like it's a programmable device. Spot, you don't tell Spot where to put its feet. You tell it to walk forward, right? It has all the algorithms to do all that. So it has some of the best APIs that I've ever seen on an automated system. And so the way to talk to it is with a protocol called gRPC, which I think is called like General Remote Procedure Call or something. It's built on which is built on protobuf. It's a way of kind of handshaking between devices and describe. It was invented by Google. Like it's really cutting edge, really, really good. Really, you can make it talk to it and get anything from it, do anything from it. The integrations are really good, but it looks more like it looks more like building a web service or building like a sophisticated internet connected something than it would look like an automation system. I think that's really cool. And we've built software that talks to it from Node.js and other, I would say like more like software engineering, software industry type of tools. That's kind of the way to think about it. In terms of its API, it looks more like an API. And it's super fast and it has tons of data. You can go look at all the docs. It's really, really good, really good. But it's pretty hardcore and capable in that way. Because it looks like a real-time system. It looks like that's what it behaves like. And yeah, it has great commands, even for just like move forward. Like it's really, really good. But as you're thinking about it, think about how you would talk to it from Python and Node.js and these kind of like advanced software engineering tools. Like that's how it was built. But a lot of times we're just driving it around, or you're driving around and teaching it landmarks. You're walking around, this landmark is here, this landmark is here. I want you to do, so they have like scripting for doing missions and things like that, and payload integrations, and also dancing. Dancing is another, the only, this is a funny thing. The only license that we have for it is for Choreographer, which is the dancing software. So, I think right. That was the adder.
That is so on brand for Loupe, right? Like we're
going to need that.
Yes.
Yeah, right.
We're going to need that one. Nothing else. We'll build the rest of it, but if you can help us make it dance easier, that would be better.
It doesn't really have any other licenses. It's not that kind of a thing, right? Like, and it's expensive, but like, and batteries are expensive, and it's like the charging stands. But like, I think the robot dog itself, if you look at the package, and they have their pricing online. Mm-hmm. I think the kind of base robot dog with the pendant and a couple batteries is something like $75,000.
I think David, you stunned a few of our listeners, coming 75? From an automation background.
Yeah.
They're just not expecting to hear that there are no licenses. Maybe a little bit.
I thought you meant the
give them time. Give them time. Give them time. They'll figure it out. They'll figure out a way to make it cost $200 before too long. But
absolutely.
And it definitely needs to dance. The other thing, and I don't know if the Choreographer light pricing is public. very low 5 digits. I will say. I'm not.
Okay.
It wasn't epically bad. And the funny thing about the choreography license is that it's required for you to buy the high-end warranty for the you have to also buy the warranty.
Oh.
They force you to do that because you're gonna crash it. Like it's gonna, you're gonna be on you're gonna slip on something, because a lot of the routines and a lot of the moves that it does, it sort of is turning off all of its balance algorithms for walking, which are really, really refined. And it's doing more like open loop, kind of like canned things. They work really well, but you will crash it. So when you break its wrist or when you accidentally fly down a set of stairs, you have to have the good warranty so that it can be repaired.
Oh, that's really cool. Again, I'm curious to see, what's going to be developed by you guys, and in general to seeing that like on the manufacturing floor. While we were discussing this, again, I was just thinking that on manufacturing lines, right, you have, for example, faults that happen, you need somebody to go and check up, or at least be the first response. I think like that would be the perfect application, right? Because you can dynamically send out one of these units, and it doesn't need really anything else except like a position. It can immediately take a snapshot of what's going on, and you can almost, I would say the proverbial the lights out manufacturing would bring us a step closer to that, because you could get an assessment of the issue before you even send a person there to troubleshoot. So there's going to be a lot of interesting cases.
Totally. And in a big facility, I mean, we were imagining for our team almost using it for things like telepresence. If there's some giant facility that's full of equipment, and even to just put a high resolution camera on a gimbal and point this camera at that limit switch while I do this stuff from my from my COVID bunker. That's sci-fi, but it's actually not that. We could totally do that, and even just to put eyes on something, to have mobility. And where there's stuff like doing different type of gas detection or other types of things where we need to take rounds, like every day walk around the construction site. Every day go do that. Every day go take a picture of everything and scan the entire thing. And even if humans are looking at that data, to go and look at, because again, that's a very unstructured environment, right? It's an unbuilt building. It's half built. To have all the people in the world that are involved in that project be able to just fly around the scan of the model from today, that's something that could solve a lot of problems for people, and justify the cost of why would we do that? Yeah.
No, absolutely. And on that same note, I remember there was a Tim Wilborn video not too long ago where he was saying how a manager was using techs or people on the floor to kind of take pictures and then convey that information to, I would say, like the engineering teams. Like, well, there you go. Maybe that's a solution or a conversation worth having with that engineering manager. You can automate that entire process. But in any case, I think it's going to be really interesting to see what people come up with. But I guess to kind of like close off that specific discussion, you're working probably with some companies that, again, are looking to innovate, probably with the R&D departments who are trying to figure out some of these applications. And I would say like still more like on the research phase than maybe like seeing it on the plant floor. Is that correct?
Spot definitely has that flavor now for us, right? Like it's definitely newer than, of all the weird new things we work on, it's definitely the weirdest and the newest, because no one knows what, people aren't clear what robot dogs are good for. People know what robot arms are good for. They've been building them for 40 years, and it's a much more mature space with lots of users. And so I think it's very cool and very interesting. I know there's something, it's going to hit on those things. It's certain, but it's really exploratory. Yeah. There aren't, I don't know. I don't know of any fleets of hundreds of them that are getting done, but if you just like putting them into these places, or putting them out on oil rigs, or putting them out in places where, they're not accessible, but you need a lot of mobility and you need to bring stuff to, those are the people that are most interested, I think.
Absolutely. And I would say to that point, as you describe, especially like the missions, like the first time it was described as going on a mission, my thought was it sounds very much like commercial drones, right? It sounds
right.
it sounds like, how can I take this $50,000 drone and have it go fly the pattern that I want. So when I think of it in relation to kind of that more commercial and those more commercial applications, as opposed to, you know, your $200 DJI Maverick, right? Or your maybe $500 or $1,000 one now. I think that makes sense. And I think that we'll see a lot more inspection and other services when we go down that route. And I think that maybe not every facility will have them, but I would imagine large facilities that are spread out or remote or very caustic, or it's just kind of a nasty environment, or maybe we put a $10,000 thermal camera on the thing and it goes and it runs around 50 places a day in order to check temperatures. I think at that price and that price point, we will see a lot more items that just make sense for robot dogs, in addition to dancing.
Yeah, and I think give Boston Dynamics a lot of credit too for taking that technology and commercializing it. Also, if you look at what they're doing, they're also building systems with their technologies and with their scanning and presence abilities to do like box unloading and stuff that's like way more nuts and bolts in terms of unload the truck, right? Like they have, I forget, is it Stretch or I forget the names because we don't work with that stuff, but they have a lot of really interesting technology and great engineers at that company to do that. And they're doing stuff that looks more like traditional industrial automation as well. That doesn't look like robot dogs, but it's still based on a lot of the same core technologies or the same kind of awesome teams. So give them a lot of credit for being really innovative. And they have, now they have customers like DHL signing a $15 million deal to, buy whatever. So I'm really hopeful for them. And I like what they're doing. They're a cool team.
No, very good. I guess let's transition more towards, more typical robots. So the 6-axis robots. I think you brought up a really good point earlier that, something to the effect of, we're not going to go build a ton of new additional automotive facilities that need 1,000 robotic arms, right?
Or
I think
we're not. We Loupe are not. Other people.
Well, I think at some point we'll be topped out, right? At some point there will be enough facilities building vehicles that we won't build thousands more of or hundreds more of those facilities building vehicles. Like I guess that is kind of my point. You guys can say you Loupe will not be building hundreds or thousands more. I will say at some point we'll be topped out of what I would call more kind of legacy solutions, right? Like moving kind of items down the way. And so you guys have been taking your motion solutions and kind of your more B&R style background and combining them with some of your 6-axis arms. Can we talk potentially about some of the novel solutions? We don't necessarily have to talk about, the actual applications, because I know you guys do a bunch of fun things like use robots to make coffee and smash pumpkins and control them with VR goggles and all that.
Right. No, that's all like searching for new applications, or even the camera robots, or it's like a playground for technologies that we want to use in other more directly commercially applicable, like our real work, where companies that you've heard of are like, we're trying to do this thing. Can you figure out how to make the robot do this thing? We're like, that looks just like the camera robot. That looks just like the coffee robot. Or we're using the same APIs because those are more like exercises and kind of fun things that we're playing with as demos, right? Demos or learning opportunities. But to get more specific about it, a lot of the stuff that we're interested in is it's more like it's really augmenting, or it's like hooking up with robots with newer software systems. So some of the stuff that we get most excited about is when we can really take over control of all the joints. Sometimes that's just spatially, like move to this location, and sometimes maybe at a millisecond or two, but it's, we're almost sort of saying, okay, robot controller, just please do what we say exactly all the time, because we have our own software. There's other systems, there's AI systems that are making decisions on the fly, because a lot of the traditional robotic systems, they have scripting, or they have legit code software in there, but it tends to have kind of like a push play and let it go kind of a feel to it, or like a kind of PLC kind of feel to it, where it's like it's running routines that are really, really repetitive. And so a lot of those things where we're hooking into new systems for decision making, or for increasing the accuracy, or for being really adaptive all the time because the part is always different. Those are things that where a lot of new software and sensing technology can make robots do new things they couldn't do before. So sometimes it's just dealing with variability, even if it's just dispensing. It's like, well, the part that comes out of the mold is squishy, and we scan it, and every time we change a path every time. Even that kind of a problem is not always that well served by existing dispense solutions. Or let's say you have a dispensing system that has a handful of servo axes because there's a few fancy pumps and there's some mixing. Like, you have this other complicated system that needs to coordinate really tightly with a 6-axis robot. There are ways to do that out of the box from the robot suppliers, like, don't get me wrong, but there's also a limit, or there's also, you can take it further. I think a common example that we see that I could talk about generally is like I mentioned in aerospace, where some of the most interesting applications were in carbon fiber layup. So they're taking little strips, or sometimes big strips, but little strips, maybe 16, 30 rows of little strips of tape. And they're flying that actuator across the surface, and they're cutting those edges of that tape at 2 meters a second. They have to lay down the edge within like a fraction of a millimeter. So if you do the math, you do the motion control math, you're like, well, we have 30 axes that need to be 30 servo axes, and these triggers that need to happen with sub-millisecond timing along the path. You cannot do that with a regular robot controller.
Are you using vision in that mix as well? Are you like detecting those edges using vision, or is that position?
No, sometimes, usually it's pre-planned, but it's just exactly at that location because they're laying stuff on top of each other and all the edges need to be aligned, or they really care about it. Like if they're a millisecond or two is a millimeter, right? Like on those machines, and that's not as accurate as they need to be. So those are examples. Or even just taking it and measuring it, or doing live compensations, scanning the part and then redoing. These are all places where there's a lot of flexibility, where new software tools or better coordination or better timing means that, well, yeah, you can take this, $50,000 or $100,000 robot and make it do something that otherwise might be like $1 million gantry to build to do that. And so in places where that's, and that opens up to places that makes it cheaper to build carbon fiber parts and makes it better. Now more airplane parts are made out of carbon fiber. It's just, those are the kind of things that we're helping people to innovate on. At least when we're going high end, or we're going in terms of like really expanding what a robot can do by like usually software or other systems, or other coordinating with other motion control systems. That's where there can be a lot of new things happening.
David, good question from our chat again. Jonathan is asking, any additive manufacturing applications? Sounds quite relevant to these new challenges. I'm wondering if you've seen, like robot arms, I've seen a demo of it building like a house, and now instead of being like a giant CNC, it is a robot arm that actually places the concrete. So I'm wondering if you have any examples. Yeah,
totally. And ABB, I didn't mention too much the ABB connection, but ABB Robotics, one of the global market leaders. I don't know whether they say what number they are, but they're in like top few, let's say, maybe top 2, top 3. They came along and acquired B&R, or ABB, the parent company, did, which is sort of how we got involved. We had already been working with robotics, but it's like, oh, cool. The one of the juggernauts just came along, and now we're part of that team. That's great because we can take all this great technology to it. And so we've also been learning a lot about just what ABB's platform has. They have really good, like their programming tools in Robot Studio are really like hands down the best in my opinion. And they also have great, they have power packs. They have sort of like value add stuff. And one of them is 3D printing. They have a great 3D printing package that helps with the slicing and like converting the code into like what the robot arm can do, and integrating in with the dispensing systems or the extruding systems. And that pack, it's like, it works great. We've helped people just use that package and maybe do some simple stuff around it. We've also done stuff that's in more where the materials or the dispensing is more tricky or complicated, or there's other motion control stuff. It's not just like a speed dependent, or it's not just, there's some limit to like what that dispensing package could do. And wherever that limit is, there's always people that are like, but we need to do this. Like, yeah, we can help you. We can help you with that. So it's a ton of additive manufacturing, squishing out every kind of goo or dispense, mixture, epoxy, people are doing that, building up plastics. Like and people are finding new ways to use that stuff because a robot arm is a cheap way to build like a giant 3D printer.
No, absolutely. See, Dave, maybe that's an
Mm-hmm.
option for you to build me that silver play button that you were
Yes.
mentioning at the start of this show. So
we can just use lots of goo to squish it out. So I want to continue.
Squish and goo.
Squish and goo. I like it. We'll just rename the theme. Squish and glue. we won't actually rename the theme. So I want to continue this conversation. We got some people to thank. So Vlad, can you play us that noise and we'll do the thing?
There you go.
Awesome. So we do want to thank Siemens for sponsoring this robotics theme. The technological tasks in modern machines and plants are diverse and often demanding. It's good to know that there's a smart answer to all the challenges regarding motion control, signal acquisition, output, closed loop PID control, edge computing, artificial intelligence, and machine learning with SIMATIC technology and SIMATIC Technology-CPUs. Now, David, this part always shocks me. So I'm going to ask you I want to look at your eyes when you see this. So Siemens is the global leader and innovator when it comes to industrial motion, robotic, and simulation applications. This is the part. So they are one of the world's biggest investors in R&D technology, spending more than $6.11 billion US per year. And they have maintained this investment throughout the pandemic. This is shocking, right? So it's a lot of money. It's a lot of robots. It's a lot of we're going to let Vlad do longhand $6.11 billion per year divided by spot robots, right? So, and they've been coming out with a bunch of amazing things, right? So the integrated and scalable SIMATIC technology automation solutions save you valuable engineering time for simple tasks, as well as complex issues, and guarantee maximum efficiency and flexibility. This means one engineering framework with TIA Portal, one control with SIMATIC Technology-CPU, one communications for standard automation, safety, and motion control with Profinet. I'd also like to throw in, if you guys haven't caught it, episode 51, we were talking to Max Kirkpatrick from Siemens, and he was walking us through all of the simulation technology that they have. And one of the things that at least Vlad and I think is really cool is you can go through the Siemens technology simulations, and you can kind of basically drop in any robot you want. You can build the cells and you can automate the cells. And so that was very interesting. And we are very interested. I think we know enough about digital twin and how many people use it to say that it's an awesome technology, and we're going to see more and more of it into the future. So that's actually one of the technologies that I'm excited for the Fortune 50, the Fortune 5000 to kind of go and continue to pioneer, so the rest of us can be able to afford it into the future. And so to kind of bring it back to one of David's previous points, so I actually worked for one of those companies that was ripping off KUKA Titan controllers, putting Siemens controllers on to drill. Well, that was a specific drill of an airplane fuselage application in there. And so honestly, some of the smartest people I've ever met. One of your previous comments, David, was something like, it's just a little bit more math. And this is like one of those themes. So I like to joke that automation manufacturing is all math, right? But robotics, it's a lot of it's not even a joke. It is just all math. It's 6-axis or 7-axis or 1,000-axis with a soft-sided robot, kind of any one of those things. I think that's very interesting. And so for me, coming from that background, it was very interesting to see, how precise, plus or minus, call it a millimeter or less than a millimeter, that it has to be. And you think that's okay. We should be able to do that, and we should be able to do that repeatedly. But then you look at kind of the tolerances of everything, and if it's a foot, we have plus or minus maybe half a millimeter. I in the past had to go to attempt to get 3 foot long ends in order to kind of press rivets. And when the tolerance is like plus or minus half a millimeter over 3 feet, and then you've got all of the critical tolerance callouts, it's nearly impossible. There are probably 10 places in the entire world that can realistically produce that, and it becomes excessively expensive. And so it is interesting to watch automotive. It's interesting to watch aerospace. It's interesting to watch kind of many of these other very precise industries force us to understand critical tolerances, right? To be able to force us to say, hey, these controllers we were doing 15 years ago, like they're okay for 70% of applications, but we're not 70%.
Yeah.
We're the top 0.1% of applications. If we actually want to do this, then we need to become much better. And I think a lot of the industry has certainly gotten better over the last 15 years. I don't know how many KUKA Titan controllers are in a warehouse somewhere in a variety of parts of Germany.
Yeah,
millions of dollars when I talked to them about it 10 or 12 years ago. But no, so I think it's very interesting. And much like the rise of a variety of these applications, I think we're going to continue to see better and better solutions come out. So we talked a lot about cobots. I don't know if you guys do much cobot work, but to kind of maybe bring that to the point with cobots, right? So you see a lot of cobots, and my first view of cobots, or my first introduction, was at a trade show with kind of that touch pendant, right? Of, hey, we can go touch here, we can touch here, it can pick it up with the gripper, and it can go move, and it can drop it. And I think that was kind of interesting, but we've seen and heard and talked to a lot of people who are using cobots because of safety reasons and because of space reasons. So I think we're seeing a lot of innovative and new technologies coming in, because we can go kind of take, hey, someone built this solution. It wasn't my solution, but I can use it for the industry that I'm working in. And I guess that kind of leads me to the question: do you see a lot of new industries, or do you guys have a lot of people who in the past had not had robots looking to come to you to adopt new robots, or looking for robotic solutions?
Yeah, I'm glad that you brought up cobots, because that's what I wanted to talk about next too. And the things that we're talking about when we're trying to hit a fraction of a millimeter at 12 feet at any point in an envelope, that's stuff that's high end, or when we're saying, let's coordinate 100 axes on down below mils, like it is opening robots into new applications. When we talk about cobots, it's also the same idea, which is it's opening robotics into new applications. It's just doing it in a different way. Not by going high end, or not by like really necessarily changing what's possible in a different way. Because to me, and actually there's nobody here complain about cobots more than traditional robot companies and integrators, which again, some integrators, if you're feeling, maybe sensitive about it, it's like, and I think the reason is because they're seen as like this like toy, or they're seen as low end. And integrators are like, people are applying them incorrectly, and maybe they are in some cases, or maybe they don't know enough about it. But I think the reason that cobots are opening up a lot of new opportunities for people to try things. Again, like that's what we're all about. Like, just try it. Like, just try a new thing. Maybe it'll work. Maybe you'll learn something, and then it'll turn into something else. Like, just give it a shot. Is that you don't have to go buy the robot and then pay an integrator $50, $100, $200,000 to build you a cell. That's a few $100,000 that you're putting on the line to hopefully have something that's going to work. So that means is like the payback has to be this, the internal rate of return has to be this. Like it changes what you would even take a bet at, because it's too expensive. It has to be a sure thing. It has, and so it's like, those are the applications that are well addressed by robots, traditional robots. And that's why that's where they really excel. But cobots, and I say this kind of as a shape-shifting company. We are an integrator, but also we also sell robots. So just buy the robot. The interesting thing to me about cobots, and when I talk with people about selling cobots or applying cobots, is one of the most effective things I ever heard was just take the cobot to the person, that anybody that's interested in it, and just drop it off with the junior engineer at that company for a week. And they will find something useful to do with it. And then you'll say, so do you want to just keep that? Should we just go ahead and invoice you for that? And they show their manager or their manager's manager, look what I did with this cobot in a week. And they're like, wow, okay, approved, right, signed. And that's how it lowers the bar of an experimentation, because that junior engineer is not going to go ask his manager's manager for $300,000. That's not possible, right? So,
and it's a no risk trial, right? Because as you said, they could just always return on it.
That totally, right? It's a low risk trial. Even if it's just, you just buy the cobot, it turns out it didn't get used. You only are betting 20, 30, 40 grand. You're not betting 300,000. That's way different, So it's like, even the kind of what it takes to try new experiments is like a much lower bar. And then they find these places where they're really useful. and these new opportunities come up. So you never would have put a conventional robot in front of that many machine tending cells. Somebody's like, I'm going to try it. I think it can make it work. And that was some junior, it was some intern probably that did that. Again, that's how they get started. And it's really lowering the bar because you didn't necessarily need to be a software engineer. Like the UI being friendlier and the teaching elements being friendlier are just, they're making it easier for people to try things. And so that's where I think it's most interesting. And we should probably also teach them a little bit about how to do safety properly.
Yeah.
Right? But at the same time, it's like, well, the robot itself is not going to hurt them in the way that a conventional robot could totally hurt them really badly, much worse. Right. So it's like, it's not quite the same risk factor. So anyway, like a lot of the integrators are like, it's not for them. It's not for an integrator. An integrator is trying to, integrator rightfully so is trying to do like a great job professionally engineering a $250,000 project or $1 million project. Like that's not, and again, there's innovative integrators that do use cobots effectively and get it, and they know what they're good for. And that's great. But like, it's kind of anti-integrator, if you ask me, because it's made to self-integrate. It's made so you buy we were looking at, you can buy cobot bases off McMaster. You can buy tables off of Vention and other part from McMaster. And it's like, you're a junior engineer that just built a robot cell. Good work.
That's awesome.
Right. And like, what are those people going to be capable of? That's what I'm excited to see. It's very different than blasting holes in airplane fuselages for infinite money. That's a different game, but it's still the same thing. It's new technology. How can we put it to use?
Absolutely. And I would say to that point, for most people in most companies, betting $250,000 plus is you're potentially betting the longevity of the company that this will go right. But if you don't own the company,
certainly betting your job. Yeah,
exactly. Right. Yes. If you don't own the company, it's your job. And anything that we can do to reduce the risk, and maybe it's you get a cobot or 2 cobots or 5 cobots and it goes really well. And you're like, hey, let's go for a $500,000 Kuka Titan, because I really want to be more safely lifting, inputting, outputting, big heavy pieces of things.
Or you work your way up there. And what I also notice, and if you read about disruption theory, like Clayton Christensen talking about low end products, they do go up the performance curve. They start, and you can see cobots doing that. We increase the payloads, we increase the speeds, we increase this, and they start to eat away at the more like establishment or the more incumbent type of approaches until they're starting taking over everything except for like the very most high end things. And that's a pattern that happens in a lot of industries. So I got to put a plug in too, because ABB has a great cobot that they came out with recently called the GOFA that's has that kind of self drive to teach and a lot of those same characteristics. Where we have one and we're really excited about it. We like to use it, and more people should know about it because UR is not the only company that makes nice cobots.
So I wanted to follow up. Sorry, Dave, I wanted to follow up on that. David, I guess like someone who's not extremely experienced in cobots and who has seen them, as I've mentioned a couple of times at shows, could you maybe give us a breakdown of, again, like different platforms? And I would say also, if someone's on the technical side, kind of looking to, again, maybe bring one of these into their manufacturing facility, or perhaps just learn about them for their own, personal knowledge, like what would be like a good starting point, like a resource, or again, like a certain brand that provides, I would say, like a bit more information than some of the others where you could just kind of dive in at maybe low to no cost?
Yeah, well, definitely you should email Loupe with all of your cobot opportunities. So put my link in the chat. I want to hear from you if that's how you feel. If I were to give the general answer, and the informative answer, obviously UR is a market leader and they created a category. So you've got to tip your hat to them for doing that. And that's cool. And, we know the people that work with them, and sometimes we do work with them in some applications because people are using them or they have used them and we need to talk to them or integrate to them. But also, when you're putting cobot cells together, it's kind of table, cobot, gripper, fixtures. Like it's just putting a few of those pieces together. I was joking. I wasn't really joking that you could almost do it for McMaster. You could almost do everything for McMaster. And I think it's, what it more comes down to like what relationships you have with the people that are going to help you, just like, here's how it runs. And, most cobot companies that are worth their salt or like have somebody that will show you the ropes. They have people, they have application people that can help you do that. We're going to be doing a lot of media around that. We're going to be showing people like, and we work with ABB on cobots. We work with a gripper company called On Robot that has a great product, and the stuff is so fun to work with. It just like clicks together, plug it in. It's like, oh, it's running. Like the gripper is gripping. Like it's not. That's what. There's nothing for an integrator to do. Right? It's just like, oh, the signal is this, and I can make it open and close, and then you just sort of build up by running it. I think. The other thing that I would plug about that is back to Robot Studio with ABB is their simulator software is great. Like you can just download and run the trial and play with the thing in the simulator without, again, that might be what gets you to get your boss to get the ABB person to come and talk to you about it, right? Like, because you can just play with the bots and the simulators just to see like, oh, can I get a feel for this? Is this something that I think I could do? Or even just like, I can put in my parts, I can put in my table, I can show the thing virtually picking it up. And then you show it to one other person who has more power or money than you. And you're like, oh yeah, it looks like you got it done. Here's your signature for your thing. Or here, yeah, let's bring that in. Let's try it. And so, yeah, it's the other shout out I would give. We're friends with them. We don't have like a distribution, any kind of relationship with them, but Vention is also really cool. For someone that's just like wants to try stuff out, or they have a lot of like pre-made kind of systems. And I don't know if they're the cheapest or, but they're certainly the most convenient and the coolest and have the best tools for, if you really just want to mock up a cell, you can mock it up in their tools, make a couple changes and click a button and like all the parts arrive. Like we've done an unbox of one.
Interesting.
That's
Based
like in Montreal on a side note. So maybe 10 minutes away from me.
Oh, cool.
Awesome.
Yeah. No, you should check them out. So again, like you just need some fixturing and tables and an arm, and sometimes there's vision and stuff like that. But I mean, that's often it's just, is it there or not? Try to pick it up. Like you can get started a lot simpler than that.
Interesting. So I like that. So just to clarify, you did say that we can go download and run Robot Studio without any extra cost for at least some period of time, David?
Yes, that's right. If I'm wrong about that, I'm going to talk to my ABB contact and make sure we'll talk to Mark. If you can run into any roadblocks, email me and we'll email Mark and he'll help people out, because it's really one of those things. Try it out. I'm pretty sure they still do free. They have free trials, and
I'm looking at the website now. It's 30 days. Robot Studio Power Packs for 30 days. You can download it.
Which I think is great. So one of the questions that people continue to ask us, and one of the big kind of issues and how can we get more involved in it, is kind of this industry in general. It's very expensive, right? Like very few things can you get 30 days or any amount of days for free. Right. So I think that's awesome. So we'll be sure to drop that in the show notes and kind of make note of that throughout all of the shows in the theme, if people are looking to learn more. I feel like we've kind of touched this next kind of area of conversation, but where do you think the future of robots is going to be? Is it going to be Spot? Is it going to be, are cobots going to eat the world? How are we going to get more robots into industry?
Well, I think there's more work for robots to do. I think there's a lot of, again, that's the purpose of we're just like, there's all this amazing technology lying around for solving new kinds of problems and pushing what robots are capable of. There's a lot of work that's been happening in research for decades that hasn't really made it into robots because it hasn't found the right opportunities or hasn't found the right economic models. But there's PhDs that spent their whole career learning, some of the control techniques on Spot. You're like, how does it move like that? It's like, look at the last 40 years of PhDs talking about how robots should move. Like that's where it came from. And so I just feel like there's really no limit to where that stuff is going to show up, because really what robots represent to me is all those software and digital systems. Like that's how they make it into the physical world. Like, so there's going to be so many opportunities if you want to move stuff around or push stuff around or drill holes or shoot lasers at things. Like you have to make physical things move. And at that point, we're talking about robots, right? It's whether it's something you build out of a custom pile of metal yourself, or it's a Spot, or it's a 6-axis. We don't really make a distinction between those, right? We're just, how do we get the software to do stuff in the real world? And I'm sure that, we all, the three of us anyway, could spend our whole careers doing that and never be finished. So that's my plan. Yeah.
I mean, it's super interesting because there's so many variables, right? Like there's not only the robot arm, but then there's the grippers, like you've mentioned. There's also the vision systems. And, I was thinking about the problem that you've mentioned of high precision. And the question in my mind was, do we solve that with very precise math and making sure that the robot goes where it needs to be, or do we compensate, using a vision system that will place that part? You know what I mean? And obviously, like, it depends on the application, on the environment.
Well, obviously,
but there's so many
we need
different,
to do all of those at the same
yes.
time.
Yes, all of those.
It's yes, right. And it's like, and then you're like, well, if we could get the vision system and we scan the part and we have it as accurate as possible and we have this crazy AI on it, then we can, it's like, these are all just like pushing further what's possible. Yeah. Again, some of the stuff that we're working on now that looks more like conventional CNCs has all of that stuff at the same time, and active laser guidance systems all the time. Like, just because it's like the envelope. So yes, it's like all of that, right? Every single one of those things is like changing what the limits of performance are. And there's going to be, there's people that'll find use for it, right? That's what we think.
Absolutely.
So yeah, it's all the above.
The people on.
Go
I was going to say the people that I know building these systems for the last 20 plus years have kind of done all of that, have the PhD that they spent 10 or 15 years researching on, that turned into, hey, I can turn this into a business that got bought by a larger business, that, this is what they are moving on. And it's kind of all of those. But then at the end of the day, you still have an operator who doesn't want to work Saturday and crashes it into the fuselage of a machine. And now we're $1 million of broken parts of an aircraft and a cell, and we're down for 3 weeks because we have to repair it, right? So somebody's going to be upset about that. Vlad, to your point, like, that's what I like about our work. And I was having a conversation with a client this past week where we were talking about, they have a really interesting, very large scale problem that they're trying to solve. And we have been talking to them about how we're going to solve it with a 6-axis robot. Mm-hmm. And what I was telling him, and I wanted to be really clear with him, was, look, we're not a robot company where the answer is going to be a robot, right? The answer is for sure going to be a robot if you're talking to a robot salesperson, right? And it's like, what's the right mix of things? What's the right mix of techniques? Should it be a gantry instead? Should we make it out of custom things? Should we instead use a robot dog? Like, that's what I like about what where we're at. It's like very flexible in terms of solving the problem. Do we solve it with vision? Do we solve it with machine? Do we just build the entire thing out of granite and Invar, right? Like, it's like, what's the right solution, right? Like that's what I like about the kind of work that we do with just like thinking of it purely from machine design point of view, instead of how do I use a robot. Necessarily.
Absolutely, and that requires a lot of thought, right? Like, at the end of the day, I would say, like, the engineering challenge of maybe just moving that robot from point A to point B, however precise that may be, the most of the time spent is on the design thinking and understanding, like, the real challenge. And again, like, there's so many facets to this whole system, right? Like, we talked about robots, vision systems, grippers. Again, like, your control systems are tight in, your data is now coming through the cloud, and again, like, your parts are changing. So there's so many moving variables that makes, I think, like, this space very exciting, at least like for the years to come. I think there's going to be more and more challenges, but also more and more opportunities to work on these different applications. Dave?
Right. And
No, I agree. I think all of this is very exciting. So I'm going to ask this question knowing full well that we're going to go over our 75 minutes ish. But
it's just a matter of how much over, Dave. I'm not stopping until you until you close the meeting. Go ahead.
That's fine. You guys hold on, because talking about the future, we will shout out another Loupe brand. So you guys run a group called Ship and Six, right? Where you guys go and kind of develop, I don't know, wild, crazy ideas that customers are asking you to do. And so I remember watching something that was like a Tetra Pak or like a variety pack machine that you guys built around a 6-axis robot. Can you talk about that a little bit? Because I feel like it solved a very interesting problem and is, very futuristic compared to what the market currently looks like.
Well, this is Dave showing his, like, I like your older stuff kind of hipness, where he's like, remember your first album that you did, that no one bought, but or no one's heard of. No, I appreciate that. We did. I mentioned that we do these exercises sometimes just for various reasons, as good practice, to show the technology in use, to really bring people into how we solve problems. And we did a live stream right before COVID, and then kind of like into the early part of COVID, of doing a new machine design that was based around B&R's track, like a high-speed shuttle track system, which is very cool. It's called the ACPOS track. It moves super fast, can electronically divert things like Tesla built like a big battery production system around the technology because it could link everything at like full top
That's
speed.
what it is.
I wrote a blog post about that. I wrote an article about that. You've seen it.
I've seen it at the facility. Yes.
Yeah. So I wrote a post. I wrote a clickbait headline of like the secret weapon behind Elon Musk's new battery factory, because they were showing Akapaz tracks in there. And again, all might be in our context. We're afraid because they're under NDAs, but I didn't work on it. So I'm just pointing at Tesla's videos.
Yep.
Anyway, we wanted to show, again, revolutionary new technology, like never been done before. Like, why would anybody, it's sort of like with robot dogs. Why would you do this with high-speed shuttles? You don't take a conveyor and replace it, put a high-speed shuttle in, and it doesn't make sense. Like, it's a different thing. And so we were thinking through, and we had talked with the packaging OEM, and they said, okay, those shuttles look kind of cool. How would you solve this problem? And they gave us they basically handed us one of their cells that they did in a really conventional way with 4 robots and multiple screw timing machines. And like, it was, it's basically how machines are built today. So like, I'm not knocking it, but it was like, they're like, how would you solve this problem? It's like, oh, get rid of all the screw machines. We can pitch everything dynamically on the tracks, and we can have the robot end effector be flexible enough with 5 servos on it to hit your rate in a quarter of the footprint. And it, by the way, it can take any bottle size between tiny one and a big one. Yep. And we did this track pack. We called it the track packer. It was like a case packing machine that could pitch and basically could do zero time changeovers, like no time changeover between products. And a really, really interesting concept. And yeah, it just had a robot at the center just to pick up the parts and put them into the box. But like, it was all the magic was in like the sequencing and the timing and the track systems. We really wanted to show people what's possible because people weren't thinking of how to solve the problem in that way. And it was such a new idea. It's still such a new idea, like these track systems, especially B&R's track systems. Like, I don't know if it's really gotten into the machine designers' heads of like, why would you do that? Because people are like, isn't that expensive? And you're like, well, sort of.
The machines are expensive to begin with.
The machines are expensive, but also floor space is expensive. Also, this machine can run triple the rate of any machine you've seen before. So what do you mean expensive, right? Like, it was just such a different solution that we really wanted to inspire people. So yeah, definitely check out the Track Packer. We have a couple links to that. We did a concept and then we built a digital twin of it. That was the real software. Like, we were like, are we gonna buy a bunch of gear and build this machine next? Like, that was us really demonstrating, like, we can build it in the simulators first. Like, then we'll go pitch it around. If somebody's interested, we'll build one, and so far, like, it hadn't, it felt too new. Like, when we would pitch people, like, people weren't getting it, like, or there was something we're missing about the explanation. I still think it's really cool, and yeah, people should check it out. If it should be revived, by all means, like, yeah, let's do it. Or it's just waiting.
David, what's the name of the B&R tech? I'm finding a few links. It's called Super Track and then Akapaz Track. Is that
Akapaz Track? Yeah, Super Track is one. Super Track is more of like, it's limited to an oval. It's limited to like a racetrack. Okay. And Akapaz Track has basically these segments where it can flip. So you put 2 track segments next to each other, and the shuttle can jump from one to the other. So it can turn left, turn right. You can build these amazing. Anyway, yeah, Dave, if you've seen it, you've seen the videos, you know what it's like. It's amazing what it does. And it can link any production. I think when you see Tesla do it, they link all their production machines at full speed. No buffer, there's some buffers and stuff like that, but it's like everything is running completely linked as if it's one machine. And you hear them talk about it. Like, they did a presentation and they were like, we looked at printing machines, we looked at bottling machines, and that's how we want to make batteries. Hell yeah, right? They did it. They're doing it. So that's the Akapaz Track, TR8. Sorry, their name.
I put up the link.
I'm going to apologize on their behalf. Yeah,
that's interesting.
No, check it out. It's been around for a couple of years now. It's amazing stuff. Yeah,
it is. I think it's very interesting. I've shown it to people within the last month because it was an issue, and I'm like, this comes very close to solving the issue that we were talking about. But no, so I like that. I feel like that's one of those futuristic designs that was certainly worth mentioning. And I think it kind of, absolutely. And I think it brings in the robot, it brings in the moving track, it brings in the vision, it kind of brings in all of those things that we were talking about. And it's one of those that it's kind of a solution that's there's a problem, but it is a solution that is waiting for a customer. if you will.
Yeah,
If someone's
right.
saying, hey, my floor space is 10x more valuable because I've run out of floor space, but it's okay. We only have customers, I don't know, once every month complaining about
Or they're
running out of
like,
floor space.
we never tried to change over that fast before. No one ever asked us to. Like,
Yeah.
well, what would it mean if you could? You know, like what could you do
Yep.
in terms of your, you know, your run sizes could be, you know, minuscule, microscopic, you know, like, and it's like, who's going to see that as an opportunity to open up new markets or run, you know, every influencer could have their own cosmetic brand because you're just running runs of 300. Like
Yeah.
those are the kind of things that those production machines would be capable of. But again, if they're just used, you're not going to replace the way you did it the old way and keep everything else the same. You know, it's like, so yeah, companies like Tesla come along and they're like, oh yeah, we're trying to solve this battery production problem. Like this is the ticket. And yeah, I really give them a lot of respect for doing that. That was really aggressive and very cool of them to do.
Absolutely. No, thank you for that. So kind of the next question that we ask everyone is for career advice, but maybe as opposed to right. But let's kind of frame it into if someone wants to do some fun, weird stuff, maybe some futuristic stuff, like you folks at Loupe, what is kind of your career advice for someone looking to get into new applications?
Let's see. I think it just comes down to practice and intention. Mm-hmm. Like at a time, like I think in the first 5 or 10 years of the company, we tried to appear normal, like on purpose. Right? We're trying to be like, we were like wear suits, you know, and we're trying to look like conventional professional automation salespeople. Really, we're like, we want to just like revolutionize everything. Like we want to like, we want to go so hard at this. And we were afraid at that time that if we said things like we say now, which is the purpose of Loupe is revolution, or else, you know, or we're not interested. Like how we even have a company, we have to work on all this boring stuff. And that's not really true. In fact, that was holding us back, because that's really what we wanted to do is like, and so like, once we really like accepted that, once we got really clear about that, then honestly, those things started coming out of the woodwork, because it was clear what we were about. It was clear that we care about innovation, we care about experimentation, we care about creativity, and the people, whether that's employees or whether that's clients or whether that's suppliers that also are aligned in that way, they're like, yeah, we see instantly right away. Like we had a company, again, major company whose name you would know. We got introduced the first time with ABB. Through ABB, through our contacts at ABB, because they already worked together. And I was used to having to like try to cold call, you know, please let me come meet with you, blah, blah, like all this stuff. In this case, ABB referred, they said, you should talk to Loupe about that, because they like to do weird stuff. And they showed up with 9 people at our office.
Oh man.
In the first meeting, because it was clear that we were aligned. It was clear that we were aligned in that way, and they could see that because we were like fearless about, no, this is what we're about, right? This is what we're doing. And they were like, cool, that's what we need. And so I guess part of it was just like owning that and just going, like, again, easy for us to say, like we had a lot of practice. We had been in business for a while, but like, I think I wish I had done that sooner, or, you know, been clear about that, and don't kind of think you need to do normal stuff or boring stuff to pay the bills. Like if you have to, please do, right? If you have to, I respect that. But like, I think there was a lot of that stuff in retrospect where I was like, I was in the wrong place, because I was working with people that didn't want to innovate things. They didn't want to change things in a positive way. And, you know, maybe they had the reasons, but, you know, why were we working together if that's the case? I think that was just like being clear about that was what has helped me a lot, especially in the last handful of years.
If I may ask Dave, I was going to ask a follow-up to that career advice answer. I guess, like, David, I mean, I would look at you guys again, like, as innovators in the space, but also a company that does things differently from like a technology standpoint, right? Like, it's not your traditional controls equipment. It's like you guys program in many ways, I would say, with more traditional like software best practices, right? So I was wondering,
absolutely.
You know, when you talk to people with when you're hiring people, right? Like, what do you typically look for, or how does it fit in a company like yours? Do you typically prefer people with more of a computer science background? Do you hire, again, like from manufacturing and then train them on the software best practices? Like, is there any maybe thoughts around that for someone who's again, like looking forward into what the space is going to transform into, and is trying to, again, like either learn new skills or kind of adapt themselves to how the space is changing.
Yeah, well, I'm going to answer your question, but I have to revise my answer to Dave's question, which was my career advice would be come to work for Loupe if you feel that way, because that's where you'll be understood.
That was the setup.
That was the setup. Thank you, Dave. I just whiffed it. Okay, I'm glad I got on the second try. So Vlad, to answer your question, I think one of the things that attracted me to controls and automation and motion control was that it was very, like, I used to say multidisciplinary. Because, and I got a general engineering degree from University of Illinois, which was general, right? It seems like useless, but it was like, you take mechanical, electrical, software, so you take all these different, because I liked all the different things, right? And so we have a variety of different backgrounds, like not just in your degree, but some people, I don't even know if they have a degree, I'm not sure. And that's because like, where do you get that knowledge that is like, if a machine's not working, it could be a mechanical problem, it could be an electrical problem, it could be a software problem, or all three, right? Or 10 of each, right? Like, and so like really being comfortable, or like finding people that are curious, people that are aligned on that value, people that are like, aren't really attached. Like now I would say anti-disciplinary, which is like, we don't acknowledge, I picked this term up from MIT. We disagree with the idea of disciplines, right? Like we're an electrical and a mechanical engineer and a software engineer. So there are places where we find that, like there are schools that have like more mechatronics focus, but it's often like you were an electrical engineer and you picked up some controls and you like played around with some software. We'll teach you enough mechanical engineering in your work for you to be dangerous. So like, but we're building these like really multifaceted people. Other time, you know, and to your point about computer science, I know what people that are really deep in computer science, and like we're nowhere near that. Like we might look like it to automation folks, but we're like not even close, right? So it's more like broad, more like breadth. And if you like, I would joke about like we wouldn't hire computer science people because they don't know that you turn the screwdriver right to make the screw tighter. They don't know righty tighty. Yeah. And if you don't know that, like you can't work for Loupe. Like, or like, and again, I'm only exaggerating a little bit. And likewise, you know, you can't be afraid of computers, you know, because it's like everybody always thinks, the mechanical people always think it's like a software bug. It's like, yeah, but what about those 5 loose bolts? I can see that on my traces, right? Like you really need to know. So it's really being comfortable, or like that kind of like very curious and like wanting to learn about everything. Like a lot of people at Loupe have that background, and I would encourage people to do that, because you're fighting against specialization often. If you go get an electrical engineering degree, it's like, how did you pick up software? How did you learn how to write software? I mean, I don't want to give this away publicly, but a mechanical engineer who learns software on the side or in their spare time is one of the best types of hires that Loupe will make, because they have such good intuition about the physical world, but they all are not afraid to learn Python or learn C++ or learn enough to dabble. Like we can teach them how to be great software engineers, like, but you know, you need to be able to go between those worlds in the work that we do. Yeah.
No, that's awesome. I think that is that is a great answer. Back to David's original answer, I would say, generally speaking, if you are your genuine self, you're going to attract the right sort of people. I know yes. I know a lot of people who wear the suit and tie when they're not the suit and tie person, right? They just want to wear their own t-shirt with their own logo on it. And yep. Right. So if you're that person, you should be that person. You are going to attract that sort of people, at least in my experience, especially within this industry. It's the people that are buttoned up and try to wear, you know, the white shirt and the jacket because that's what they think everyone wears, because that is the that's the European
uniform.
Standard,
it's a way to not
right?
stand
yes.
out. Yeah.
Yes.
Right.
Yes. That is
it seems safe. It seems safe. It
does.
To do. But yeah, anyway, sorry, I'm jumping on you, Dave. Yeah,
no, it's good. But yes, it seems safe, but you're only going to get so far being safe. And if you want to go build weird stuff, playing it safe is never going to get you there. That's awesome. So, do you have a couple of pieces of content or reading materials for us, David? I know you gave us some great answers before. We're all excited to see what you've got, especially Vlad's Audible account.
I'm just here for Vlad subscribers, first of all. But I think what I would call out, definitely Loupe's LinkedIn is like our core, like everything that so much of what we do is happening there. I'm really proud of what we do there. We started something after we did that music video where it was so fun to make robots dance that we wanted to keep doing it. So we made a TikTok of spot dancing that's called Robo Choreo. So if you're on TikTok at Robo Choreo, and you can see how much ridiculous fun we have with Spot. And then, yeah, I mean, we have mirrors up on YouTube as well, like of most of the stuff that we put out. I mean, really, it's like we do so much with video that's what I think is probably the coolest to check out. I'm sure I mentioned Shape Up the last time that we talked, because that was so much of what we do with our iterative processes and our agile processes was basically, it was based directly on that. And the other one that I just sent to everyone at the company for the holidays was a book by Austin Kleon called Show Your Work. And he wrote a book, he wrote a few different books. He wrote a book called Great Artists Steal, but Show Your Work is really about being creative in public and just putting whatever you're doing, just put it out there. And to your point, Dave, like it's going to attract the right people that are aligned with you. You're going to learn things. It's going to help you develop your skills. And if anybody thinks that Loupe does great videos, you should go look at the first videos on our YouTube page. They're horrible. And like Austin Kleon would be proud of us having shipped garbage into the point where we can do what we do today. So anyway, Show Your Work, probably easy read, fun, fat marker book, really good stuff.
I remember you unboxing like 54 of those and like 54 sets of like wrenches or whatever else that look like fanny packs right before Christmas.
That's right.
So we'll shout out the Unbox channel, which if you want to see people unbox things because it's for their work, you
and
should
Dave's
go watch
unbox
that
too. That was a good one too. So we'll have to dig that out of the archive someplace. It's lost to time.
Hopefully, right? But no. So this has been amazing. Thank you so much, David. I'm going to let you wrap it up into who should reach out to you. I know that we've pimped the Loupe is potentially looking for some more people, but who should reach out to you? Who should connect with you?
It's really simple. If you were horrified by what I said, which would be a natural reaction, you'll know it's not for you. If you're like, yeah, hell yeah, then it's really that simple. You'll know, your body will tell you if you're excited about what you're hearing about. If you're horrified, that's whether to email or not. So, I hope to hear from the like-minded folks out there who agree that there's cool new stuff to try and it's exciting and fun.
So I love this. This is the show that has potentially gotten the most off the rails of any show that we've ever done. And so we may have actually, thank you. We may have actually run over more than we've ever run over. And it's actually my fault for once, but thank you, David.
You called it.
Yes, record. I did call it. I warned everyone. Thank you, David. Thank you everyone for listening. At some point, David will be back for a third episode and
I'm coming back.
You will be back. He will be back at some point. Yes.
And maybe in person, hopefully in person, hopefully we'll get a chance to.
Vlad just like,
Loupe.
I love it. So, if you guys have liked this, please go ahead and give us a thumbs up, rate us 5 stars. If you're listening via podcast, you can do it on Apple, iTunes, or Apple Podcasts because we changed the name. You can do it on Spotify. You can do it on Audible because some people listen on Audible. Feel free to leave us a comment. Go to manufacturinghub.live where you'll see this show on the shoulders of giants and everything else that we put out. And feel free to reach out with David, Vlad, or myself if you guys have any questions. Until next time, we'll see you all soon. Thank you.
Thank you, everyone.
Bye-bye.
Thank you, David.
Thanks, guys.
Appreciate it.